Somewhere beneath the yellow silt of a river that has drowned more people than almost any river on earth, there is a secret written, not in stone, not in scripture, but in blood. It has been there for 7,000 years, passed silently from mother to child, from father to son, surviving famines, floods, empires, and invasions that erased entire peoples from the map. And when geneticists finally decoded it, they found something that should not have been possible: a population of over 1 billion people, spread across a landmass larger than Europe, carrying the genetic signature of a single ancestral group that never truly disappeared. No conquest erased it. No migration diluted it beyond recognition. It simply endured. And to understand how, we have to go back to a muddy floodplain in northern China, long before anyone had ever heard the words Egypt, Sumer, or Rome. The story usually told about the birth of civilization follows a familiar script: Fertile Crescent, Tigris and Euphrates, wheat, barley, ziggurats, cuneiform. From there, so the theory goes, the idea of civilization radiated outward, carried by traders and migrants until it reached every corner of the ancient world. For decades, this diffusionist model shaped how historians understood every complex society that ever existed, including China. Surely, the thinking went, something this sophisticated must have borrowed its foundations from somewhere else. But the genetic record tells a very different story, and it begins not with grand monuments, but with something far more humble: a grain of millet. Around 7,000 years ago, along the middle reaches of the Yellow River, in a region geologists call the Les Plateau, a farming culture took root that would eventually shape the ancestry of nearly a fifth of humanity. Archaeologists know these people through sites like Bampo and Zhangjiai, villages of round pit houses arranged with striking social order, surrounded by storage pits filled with charred grains of foxtail and broomcorn millet. These were crops domesticated independently, thousands of miles from the wheat fields of Mesopotamia, adapted to a cold, dry, wind-blown landscape that would have killed most Middle Eastern crops outright. This was not imitation. This was invention, born from necessity on the other side of the world. What makes the Yellow River culture extraordinary isn't just what they built. It's what they left behind without knowing it: bone, tooth enamel, fragments of DNA, locked inside mineral structure for millennia, waiting for a technology that wouldn't exist for 7,000 years. When ancient genome sequencing matured in the 2010s, researchers finally had a way to ask a question that had haunted historians for generations. Where did the ancestors of modern Chinese populations actually come from? A landmark study published in the journal Science in 2020, led by geneticist Qiaomei Fu and colleagues at the Chinese Academy of Sciences, sequenced dozens of ancient genomes spanning 9,000 years of East Asian prehistory. The results were staggering in their implications. Populations overlap. A demonstrable, traceable lineage connecting Bronze Age farmers to 21st century villagers working the same fields their ancestors worked when the pyramids of Giza were still centuries from being built. Compare that to what was happening in Europe during the same window of time. Around 5,000 years ago, pastorally, saint populations from the Pontic steppe, the Yamnaya culture, swept westward in a demographic event so severe that, in parts of Britain and Central Europe, researchers estimate they replaced up to 90% of the existing male lineage within a few centuries. This wasn't gradual blending. It was near total genetic turnover, documented in landmark ancient DNA studies out of David Reich's lab at Harvard. Modern Europeans are, genetically speaking, a layered mosaic: hunter-gatherer, early farmer, and steppe herder ancestries stacked unevenly across the continent. Nothing about European ancestry is a straight line. It is a palimpsest, written over again and again. China's genetic story took a fundamentally different path, and the reasons why are almost as fascinating as the discovery itself. Geography built a fortress. To the west and southwest, the Himalayas and the Tibetan Plateau rise into some of the most impassable terrain on the planet. To the northwest, the Gobi and Taklamakan deserts form a dead zone that swallowed armies and caravans alike. To the east, the Pacific. Within this natural enclosure, a population could expand, absorb its neighbors, and rarely face the kind of total replacement that reshaped Europe and parts of Central Asia. But geography alone doesn't explain everything, because the Yellow River farmers didn't stay put. Around 5,000 years ago, they began pushing south, following river corridors into the Yangtze Basin, a region already home to a completely separate Neolithic tradition. This was the world of Hemudu and later Liangzhu, sophisticated rice farming societies that had been cultivating wetland paddies for thousands of years, building pile dwellings on stilts above the water, and crafting jade with a precision that still stuns archaeologists today. These weren't primitive foragers waiting to be civilized. They were an entirely independent experiment in complexity, with their own trajectory toward urbanism, ritual, and social hierarchy. When these two populations met, something happened that geneticists find almost as remarkable as the northern continuity itself. Instead of one group annihilating the other, the genomic data suggests a slow, layered process of intermarriage and cultural fusion stretching across many centuries. Modern southern Chinese populations still carry a detectable signature from these ancient rice farming lineages, distinguishable in certain maternal and paternal markers, even as northern ancestry became dominant almost everywhere. It's a genetic gradient, not a hard border, fading gradually the further south you travel, the ghost of an independent civilization still whispering through the DNA of the living. The Yellow River expansion didn't stop at the Yangtze. It pushed westward too, into the high plateaus that would one day become Tibet. And here the story takes another unexpected turn. Tibetan populations today carry ancestry linked to early East Asian farming groups, but they also carry something those farmers never had, an extraordinary adaptation, something even stranger. This particular version of EPAS-1 appears to have originated not in modern humans at all, but in Denisovans, an extinct cousin species of archaic humans known mostly from a handful of bone fragments in a Siberian cave. At some point, deep in prehistory, early human populations on the plateau interbred with Denisovans, inherited this life-saving mutation, and passed it down for tens of thousands of years until it became essential for a population that would arrive far later. Without that ancient, almost accidental inheritance, permanent human settlement above 4,000 meters might never have been possible at all. By roughly 3,000 years ago, the broad genetic outline of what we now call Han Chinese ancestry had essentially stabilized, a dominant northern lineage layered with regional admixture from the south and west. And then came the true test of that stability. Dynasty after dynasty, invasion after invasion. The most dramatic came in the 13th century when Mongol armies under Genghis Khan's successors conquered the entirety of China, establishing the Yuan dynasty. You might expect a conquest of that scale to leave a massive genetic footprint. Instead, studies of Y chromosome lineages in northern China find only a modest Mongol genetic contribution, a fraction of what might be expected from a century of foreign rule. The explanation lies less in biology and more in bureaucracy. China's imperial examination system, built on mastery of classical texts and Confucian philosophy, created a powerful incentive for conquering elites to assimilate rather than dominate. Mongol, and centuries later, Manchu ruling families increasingly intermarried with Han elites, adopted the writing system, and within a handful of generations, their distinct lineages dissolved into the much larger population they had once conquered. That writing system deserves its own moment of wonder, because it may be one of the quiet reasons Chinese civilization never experienced the kind of total collapse that ended Bronze Age Mesopotamia or classical Rome. Chinese characters are logographic, carrying meaning independent of pronunciation. A reader in Beijing and a reader in Guangzhou can speak mutually unintelligible dialects, yet read the exact same page and understand it identically. That single feature allowed political fragmentation, foreign conquest, and centuries of regional divergence to occur without ever severing the thread of cultural continuity. Empires rose and fell. The script endured, and where the script endured, so did a shared identity resilient enough to outlast whoever happened to be sitting on the throne. None of this means Chinese ancestry is some kind of untouched genetic time capsule, frozen and pure. That idea would be its own kind of myth. The reality uncovered by modern ancient DNA research is more interesting than purity, its resilience through absorption. Waves of migration, intermarriage, and cultural exchange occurred constantly. But rather than replacing the founding population, they were folded into it, generation after generation, until the boundary between conqueror and conquered simply ceased to matter. It is a strikingly different model of how civilizations survive, not through isolation, and not through total demographic replacement, but through a kind of genetic and cultural gravity strong enough to pull outsiders into its orbit in one short window of observation, with no clean precedent anywhere in the scientific record. And then, just to make things stranger, NASA's Sphere-X mission detected organic molecules drifting in the gas cloud surrounding it, the same class of carbon-based compounds considered building blocks for biochemistry, embedded in the halo of an object already estimated to be 10 billion years old. If life, or the raw chemical ingredients for life, really can hitch a ride between star systems frozen inside objects exactly like this one, then what passed through our solar system in 2025 may be the closest thing to direct physical evidence of that mechanism that we have ever observed, drifting quietly past Mars and Earth while most of the planet had no idea it was even happening. As of right now, in the summer OF 2026, the object has already swung past Jupiter and is accelerating outward, leaving G the inner solar system for good. Ground telescopes are losing their grip on it. The observation window has effectively closed. Within a decade, it crosses Neptune's orbit. Within a century, it slips past the Oort cloud, the loose, frozen edge of everything we consider ours. Within 1,000 years, it will be drifting through the cold, dark gap between star systems, carrying its 22 unanswered anomalies and its 10 billion-year-old chemistry back out into a galaxy that we now have direct evidence is apparently full of things exactly like it. Every paper about it that gets written from here forward will be working from a data set that is now permanently closed. We got one window. We are not getting another, not with this particular object. But here's what makes this bigger than just one comet, one telescope, one extremely strange year of data. A new observatory, the Vera Rubin telescope, is coming fully online right now with detection capabilities that dwarf everything we've used so far. In the entire history of astronomy, across nearly a decade of dedicated searching, we found exactly 3 interstellar visitors. Rubin alone is expected to find dozens every single year once it reaches full operational capacity, which means the era we're sitting at the very beginning of right now is the era where interstellar objects STO-P, being once in a decade headline events, and start becoming routine discoveries. Dozens of frozen ancient fragments from other star systems passing through our neighborhood constantly, the vast majority of them probably perfectly natural, ordinary comets that simply happen to come from somewhere else. But some of them, statistically, almost certainly won't fit cleanly into that explanation either, and we are only now building the instruments capable of even noticing when that happens. For the entire 4.5 billion year history of this solar system, objects like this one have likely been drifting through, completely unseen, unrecorded, unnamed, because we had no eyes capable of catching them. We only built those eyes in the last decade. And the very first time we pointed sufficiently advanced instruments at one of these ancient travelers and actually looked closely, we found 22 things we cannot fully explain. A chemical signature with no comfortable natural precedent, an alignment so improbable it would get flagged in any serious laboratory, and a nickel anomaly that defied every comfortable explanation, and then disappeared before anyone could close the case. So before you decide